Hello friends, welcome to my class. In the last lecture we have studied about the wind load. Today I am going to tell about you earthquake load. First of all you should know what is earthquake load. Okay. Earthquake load is the load caused by the earthquake. Okay. It is a natural disaster load caused by natural disaster. So how our model will be affected if the earthquake occurs or not. Okay. So we will study about that today. Go to new project. Define a frame. Okay, now name it. I am naming it as 603. Okay, click on next, finish. Go to geometry, run instruction with that. I am taking a common example here. I am taking a bay frame. Okay, simply select it 8 H. Okay, H here. Now here select it 3, select 3 again, select 3 again, apply. Now transfer this model. Now assign the material to it. Go to general, define rectangle, 0.2, 0.3, add it, define a circle, 0.2, add it. Now first of all assign a material circle, beams parallel to y-axis, selected beams. Now rectangle, select beams parallel to x-axis and select beams parallel to z-axis. Assign the selected beams. Now I click on 3D rendering. You can see that whole material has been assigned. Okay, now close it. Okay, now click on support, create. I am giving you a fixed support. Okay, so select front view, assign to selected isometric view. Okay, now loads and definitions. Now in the earthquake load, before the case of in the previous case, in wind load we have first we doesn't have defined it first. Okay, so in the earthquake load we have to define it, then only we can define the other loads. Okay, so first of all define the earthquake load and apply it, then define the other loads. Okay, now go to definitions, double click. Now earthquake load is also known as seismic load also. So here we define a seismic definitions. Okay, we will give seismic definitions. So click on seismic definitions, click add. Okay, now here you can see a dialog box is open. It shows seismic parameters. So here we have to select a type. So I will selecting a type of IS. Okay, these are all the codes. You should know these codes. Okay, you should study first of all about these codes. Okay. So this is IS 18. I am taking IS 1893 2002 2005. Okay, include 1893 part 4. Go to click on generate. Okay, now here we have to give the name of the city. Here I am taking Agra. Okay, then keep it a special RC movement. Okay, now select it important building, select soft soil. Okay, you can select as your parameters you want it. Okay, according to the problem. Now select the damping ratio. Okay, you should give it selected 0.05. Okay, and for as a problem it depends upon a problem. Okay, so you have to give the periods also. Now here I am not taking this. Okay, according to the question you have to do it. Okay, now click on generate. Now click on add. Okay, now you have to give the self-weight factor, add it 1. Okay, now the load has been defined. Okay, now we will assign this. Okay, first of all we are taking earthquake load, so select seismic. Now EL for first of all for positive x direction, for x positive. Similarly EL x negative, Similarly, L Z positive and EL Z negative. Okay. Similarly, give the names of dead load and live load also. We will define it. We will assign them afterwards. Okay. L1, L2. Okay. Now, first of all, assign this earthquake load. Okay. First, add. Go to add. Now here, go to seismic loads. Here you can see. Okay. Now select positive x for positive x plus x direction, and for factor should be 1, positive 1, close. Now similarly for second, select x seismic load. Now here select -1 factor. Okay, add. Similarly for z axis, go to seismic loads, select z direction, positive 1, add. Now for z negative, click on add seismic load, z factor should be -1. Okay, now add it. Now you can see the whole earthquake loads have been assigned. Now you have to assign the dead load and live loads. First dead load, so first of all give it safe self weight, assign a self weight. Okay, add self weight. Now member load, add member load -4 kN I am adding here. Now you should assign the flow load also here. In the both the cases, in wind load and the flow load, in the wind load and the earthquake load, you have to assign a flow load also. So here assign the flow load in the dead load. Pressure should be -4, and the specific range has been assigned here. So for the earthquake load, I am assigning the range of 3 to 33. Minimum should be 3 meter and the maximum is 33 meter. Add it. Okay. Now see the flow load has been assigned. Now in the live load also give the flow load. Only flow load will be given in the live load also. Okay. Similarly as we have done in the wind load. It's in the case of the wind load. Okay. Now minimum should be 3 meter, maximum 33 meter. Okay. Add it. Okay. Now assign the self weight. Assign to view. It will be assigned to view. Now the member load in the live load. Dead load. Select beams parallel to x-axis and select beams parallel to z-axis. Now assign the member load to it. Okay. Although you can see that whole structure loads have been assigned, so we will see the results. Okay. Analyze or analysis, save. Now it shows us there are 0 errors, so there is no problem in our model. Click on done. Go to cross processing for the results. Okay, you can see here results. Okay, so I will click on animation, deflection, see. Okay, so deflecting a little bit. Okay, so it is fine. And so now our structure has been safe. Okay, so this is all for today, and guys, stay tuned to my channel, and please do subscribe if you want the updates. Do comment if you have any problem, and please like and share if you like my video. Thank you friends.